All right, let's get started. So we're finishing off proving theorems about triangles. So this is what we learned last time, for example, was a midpoint theorem, that if we make these at the midpoint, then this part actually becomes equal to this part right here. This is actually the same as this. So it's basically literally just by doing the midpoints of everything, we're getting this segment equals the midpoint. We're essentially making three triangles that are basically all equal to each other. The next one, so now we're going to prove the triangle midsegment theorem. So this states that a midsegment of a triangle is parallel to the other triangle. So before we just said, hey, this segment is equal to this segment. That's the one we did before. Okay. All right, no problem. So what we're going to do here is, first we said if they're parallel, we're going to say that they're parallel. So in the diagram, they're parallel, blah, blah, blah. Well, we're saying the mid-segments become parallel is essentially what we're going to say in this one. So give me a second here. Let's prove the first step. So in order to prove the first step, what they're going to say here is we're going to define the vertices. So we did the activity that proved it. Now they're like, well, let's say the actual thing. So we have this triangle. And if we wanted to prove it, we have to define that these are points that make a triangle. The next thing we would have to do, I do have to click the next slide. The next thing we have to do is say what the midpoints are. So this, again, we're just walking through how to do a proof. Before, we kind of did an activity that proved it. To do an actual proof, you have to give your statement and your reason, kind of like writing an essay in English. So we're just saying, like, first, except unlike English, you can't assume certain things. You have to state every little detail, unfortunately. So it's like, first, we're going to make a triangle. Second, we're going to start making midpoints of this triangle right here. And after that, what we're going to do is, well, we're going to say, we're going to define the midpoint. So they're kind of using algebra to say, like, hey, if we add these two together, divided by 2, we get the midpoint. So they're just defining it. In geometry, I don't really go into this much detail, but it is necessary on the test, unfortunately. Then they want us to find the slope. So they're finding the slope of the point, which ends up being a huge hassle because you're like, okay, we need to find the slope of one point midpoint and the other midpoint. Then after we find the slope, we're going to match it with the other slope. We're going to say, oh, look, after we do all this work right here, the slopes are the same. Again, we use a lot of GeoGebra, so using these formulas is more like just head knowledge for the test. So this is a lot, but all they're saying is basically, I said I'd keep it brief, but I feel like you guys would be a little confused by this. All it's saying is like, hey, where's my pen? All it's saying is like, hey, if we go halfway between the y values, we would get this point right here. And if we go halfway between the x values, we would get it right here. So that's all it's saying is let's add up this x. Let's add up this. Oh, making me sign in again. Why? It was working just fine. Yeah, that's fine. Okay. Sorry about that, guys. We're going to take this x, subtract this x, and that'll give us this length. If we divide by 2, we find the midpoint. If we take this y, subtract this y, and divide it by 2. So subtracting it gives us this. If we divide it by 2, it gives us that point. So doing both gives us this point. So that's all they're saying here. And then they're just finding the slope. So they're taking what they have and finding the slope. Oh, I said subtracting. I meant to say adding. I'm so sorry, guys. And then if we look at it, it would be parallel to the same line. So now we're going to do it with the other points. So they're going to keep doing it over and over with all the points. So let's try to prove this. So the first thing that they're giving us is like, hey, these are midpoints. They're telling us that we're going to do it with df. So now we're going to prove that df is the same, is parallel to this. So we're going to prove a segment is half the length. Oh, that's what we're doing. So it's going to end with us saying that it's half the length. So why not just start off there? We're going to prove that they're half the length. So this should be half the length. That's our proof. So might as well, it helps to know what we're working towards. So in geometry, it really, like when you're doing a proof, you have to know what you're working towards. That way you can do little steps to get there. So this one, DE are mid-segment. So we have to say that they're mid-segments. So in other words, DE are mid-segments of that. So we have to figure out some way that tells us that's that. So for example, DE is half of AC. So first, let's see here. Those are equal. Let's find one. So one that proves that DE is half of a segment. Also, this is a really big proof. Arbitrary choose segment that. Oh, there we go. Derp. The one that says midpoints. Come on. Now we needed to find a midpoint. Well, a midpoint is when you add the x's and divide by 2. So, in other words, half of a segment. So we can say that defining the midpoint, we can say that DE is half of AC, but they don't want that as a midpoint. Okay, great. A transversal cutting that, nope. Oh my gosh, why did they give you a proof this big? Yeah. No. That's going to be a midpoint. Oh my gosh. Defining midpoints. Well, defining midpoints would say that they cut it in half. Let D, E, and F, B be midpoint. There we go. So this is just saying that because it says respectively, this word's actually really important. It just means in order. So we're going to say that D, so let's say I have this triangle A, B, C. D, if we're talking about respectively, D should be the midpoint of BC, or AB, sorry. So this is point D, because D is first and AB is first. E goes to BC. So BC, this one should be an E. And then last is F, and that's going to cut AC in half. So this is our F. So it helps when you're doing this to draw the triangle on the side, just to kind of keep track of what's going on with your proof. So the first thing we did was create this triangle. Next thing we did was make our midpoints. All right, the next thing is an arbitrary choice. So we're going to pick a random thing. So we're going to pick DE arbitrarily. It's just saying we're going to talk about DE. I don't know why this is a step, but we're going to talk about this one. All right, next we're going to say that midpoints are parallel to the non-included side of the triangle. So it's just saying that this is parallel to this. So we're going to say that DE is parallel to AC. So let me see that. Right. I guess we're using this one. So we're going to say that's parallel, and we're also going to be talking about DF. So we're also going to be talking about this one right here. So DF is parallel to BC as well. I don't know why we're doing both at the same time. The next one is, I'm going to keep doing the parallel thing. So we said that they're parallel. Next thing, now that we said that they're parallel, we're going to also talk about how they're half lengths. Segments are parallel to the non-included side of the triangle. Definition, oh, they forgot to capitalize it. So we're going to create a transversal line. So we're just going to create a line that cuts it in half. So we're going to create some kind of transversal line. So I'm going to do this. We're creating a transversal. So they're going to say AB is cutting DF. AB cuts DF. And this cut. It's just saying that they cut it. I don't know why this one's necessary. I wish I had a better answer for you. Next, it's going to say corresponding line theorem. So they're just kind of saying that, hey, if this was a line and BD cut it up, since they're parallel lines, then we can say that this angle is parallel to this angle. So that's why they're that's why they're doing it. They're trying to say, hey, it's a transversal. It's a line going through parallel lines. So that means that ADF is going to be parallel to ABC. So they're going to say that this angle is parallel to this angle. Now I see why they're talking about, because they're talking about corresponding angles. Then because we're doing the other transversal, they are also going to say that this angle, this angle over here is parallel to this angle over here. That's because this line is parallel, or I should stop saying this line. They're saying that AC, this line right here, is parallel to DE. So let's try to find those angles. So we're going to say that these two angles are equal, and I'll explain it right now. So we're saying that angle A, FAD, this one right here, is parallel to EDB, this angle right here. And the next one saying that angle D, ADF, this angle, is equal to this angle, DBE. So the green angles. I'm sorry, I know I said I would keep it short, but they gave me a long proof. Next one is definition of a midpoint. Well, the definition of a midpoint is just saying that point D is going to be parallel, or it's going to be the middle of AD. So, in other words, one of these two. They're giving us two of them. So we can state either one. Either one should be correct. Apparently not. So they want this one. I don't know. AF is half of AC, and that is the definition of midpoint. So they're just being really picky right now, unfortunately, guys. I'm sorry. So they want you to say, like, hey, because it's a midpoint, AD is equal to BD. That's just them being picky. Either statement would have worked. This one, or this one technically would have worked for that definition. Then they're saying ASA. So they're just saying that this works because we're saying that, hey, we have an angle, and a side in the middle. Angle, and a side in the middle. So this triangle is equal to this triangle. So we can just say that those two triangles are equal. This triangle right here is equal to this triangle right here. So from there, they're saying, hey, we're going to use the definition of a midpoint again. Well, I have a feeling we're talking about this one. And of course, they're changing up what they mean by definition of a midpoint. So now, since they're talking about AD and DE, they're going to be using this angle. Why are they being so picky? All right, guys, I'm sorry. They're just being really, really nasty right now. Since they're saying corresponding parts go with corresponding sides, we're going to say that things are congruent. So the only things that are congruent are these ones. And we're going to be doing this one for the last one because it's a transitive property of equality. So this one, guys, I'm sorry. Usually I understand Admentum's logic, but this one they're being really picky. Basically, you're just supposed to be able to go through the proof, but what ends up happening is they made me frustrated. So I can understand when you guys get frustrated. But as long as I'm understanding what you guys are saying, how you're going along with your proofs, that's all that matters to me. So when I'm looking, if you guys have a proof on the test, I will look into it. If you get lower, then what's necessary to pass to see if I can give you some extra points, because you saw Admentum's picky. The next thing that we're going to say is medians. So a median is a midpoint to a vertice. So median, midpoint to a vertice. So you might want to write that down somewhere or highlight your notes if you're printing out notes. Regarding the line segment, middle angle. Now let's study the proof. So midpoints of two sides of a triangle. So basically, whenever we're talking about median, we're not talking about it like it is in statistics. Median is midpoint to vertex. Midpoint to the vertex. Obviously not the opposite vertex. I'm not going to say the midpoint from here to here. That's just a mid segment. Is everyone kind of getting this so far? I know I've kind of like blundered on some of it, but is it kind of making sense? Besides Admentum being really picky? Everyone good? Our next one, what we're going to do here is we're going to do this activity. So I'm more of a fan of them doing the practical proofs. Practical meaning that we're actually like applying it and stuff, as opposed to the handwritten proofs. So we're going to use these existing midpoints. So they already gave us midpoints. And now using the existing midpoints, we're going to create medians. So the definition of a median, we're going to take a line segment. So it's a line segment from the vertex to the opposite midpoint, the vertex to the opposite midpoint, the vertex to the opposite midpoint, and then we're going to create this point right here in the middle. So it always creates a point. Luckily, they all intersect. It could be possible for them not to intersect, but when it comes to triangles, they all intersect in here. I believe they're going to tell us the name of that sooner or later. Using this, what can you observe? What do you observe about the way they intersect? They all intersect at the same point. That's honestly what I see from it. They probably want you to answer something else, but that question is way too broad. They all intersect at the same point. And that actually might be what they're trying to say here. Yep, they all intersect at the same point. They say single point, but it's all intersecting at the same point. Place a point on the intersection of the three midpoints. Now change the positions of vertices A, B, C, and observe how many changes happen. So place a point at the intersection. Now change those vertices. Okay. So what they mean by that, they're telling us to place a point at the intersection. All right. So I'm going to grab my point, put it right here at this intersection, and they want us to mess around with the corner. So we're just going to go to move, mess this around, whoop, and we see that they always intersect. They're never changing. No matter what type of triangle we make, it's always going to create this point that changes. So let's see what they say here. Is there any change in the way that it intersect? No. The medians still intersect at the same. All three of them are medians. So I guess I could say the three medians to be more specific, because they're saying like all three medians. So the three medians still intersect at the same spot. How might you prove your observations using algebra, this briefly given outline? Ooh, gosh. How am I going to prove this using algebra? So algebra, I feel like they're getting way too specific when they want you to use algebra. So let me see how they would want us to do this. Well, we would say that we have 2 points. One's a midpoint, one's another point. So the way I would prove it would be by just writing the lines. So you don't have to get too much into algebra here, because I feel like what they want you to do is like algebra 2 level stuff. So without getting into too much details, is I would make an equation for each line. I'm going to make an equation for each of the lines and solve for where where two of them intersect. So if you guys took algebra recently, you might still remember that when two lines equal each other, they intersect at one point, right? So that's what I'm saying here. We're going to make up an equation, y equals mx plus b, and another like y2 equals m2 x2 plus b2. The reason why I put a little subscript 2 is saying that it's a different line. So this is a different line than that line. And then I'm going to figure out where they intersect by making them equal. So I'm just going to say, figure out where they intersect, just to make it simple. Make an equation for two lines and solve for where where two of them intersect. From here, I will take the point and see if it works on the last line. So what I mean by that is I'm going to make my equations, see which x and y value they cross at. So by making them equal, I can figure out where they cross at. And then I'm going to take this x and y and plug it into the final point. I guess I should put a 3 here because we had 3 lines. Keep in mind that 3, whenever it's a subscript, it's not saying multiply, it's just saying like, hey, this is a different line entirely. We're just using a different variable. So that's how I would do it. I'm sure they're going to give a really long-winded explanation on what you should do. So they're saying like, hey, like find, then calculate the midpoints. So they want us to calculate all of the midpoints, use the point slope formula, which I already did technically. can build the medians. I can solve. So here's the part that I said. Solve where two of them intersect. Finally, I can prove that the lines are concurrent, meaning that they intersect at the same spot, by seeing if it works on the last line. So that's all I said. They just used bigger words and were more exact. So you can write down on here, I would give myself maybe a 3 because I had trouble starting. It. I was like, I did not know where to begin. So I did 2 lines because in algebra, when we studied intersecting lines, we only learned how to study for 2 lines that cross each other. Now they're talking about 3. It's like, well, where do we start? So we had to start with the 1, and it turns out we were right. All right, so this is just saying that medians intersect. So we proved that all of these intersect. So in that activity, we learned that all of these intersect. That's a concurrent triangle median theory. That just says if you have a medians, all the medians will intersect at one point. Now here's the proof. So in this one, they're like, this is way above your guys' head, so they're just filling it out. We'll prove that they're concurrent triangle theorems. First 6 steps of the proof. So this is just how we start off the proof. They're like, hey, we're going to start off the proof by listing these triangles. They're doing the subscripts, like I said, so they're calling this x1, comma, x2, and it could be, or comma, y1, sorry, comma, y1. This is the first point. This is the second point. This is the third point. And again, they might not label it this way. They're just saying generally. Here's 3 points. They could have made this their point 1, so x1, x2. So it can go anyway. Then what they're saying is we're going to do rigid transformation. So we're going to move this over. And in the coordinate plane, we're going to move those points. Any property, anything that we're going to do with this other made up triangle that we did over here will be the same as that over there. So then we're going to let these numbers be real numbers. So we're going to double it. So let these be real numbers of the vertices. They're going to essentially double it, and then they're going to find these middle points. Right here. Let these be real numbers, and they're saying what's happening here. So they're going to double the size, making it that. Let D and E be midpoints. Defining the point BC, BR, BC, the points that we've found. So then you can always click this picture to kind of see what they found here. They're saying that if they double it, they're going to essentially make this triangle here, is what I believe they're saying. Definition of midpoints. And they're going to do it with, I believe they're just going to do it with all 3 triangles and then find the middle to that triangle. So unfortunately, like I said, all the proofs kind of get a little crazy here. From there, they're going to keep doing it. Equation of the line, that, oof. So don't worry so much about these ones, guys, because like I said, this is more algebra than geometry. It's good to understand how to do this, but I wouldn't worry too much about this for the test. If this is on the test, I can explain it, but I feel like they're getting way too advanced. So the summary, all you need to know from all of that stuff that we did from yesterday and today can be summed up right here. Triangle sum theory. All the angles add up to 180. Yep. Base angle theorem. This one is saying that if a triangle is isosceles, then they have equal angles. So let me kind of do this. So this A, B, C, we're going to use this triangle. This one says that angle A plus angle B plus angle C equals 180. The next one says that basically if AC is equal to CB, then angle A equals angle B. And like I said, in geometry, they want you to use this measurement. So they're just saying that if this is equal, then these two are equal. The next one is the mid-segment theorem that says that a mid-segment of a triangle. So if we have this triangle, these are our midpoints. It says that this angle is parallel to this angle. So this is the sign for parallel lines. You kind of do these two little arrows. So these two are parallel. So that's what this one says. And the last one says that the medians, the vertex to the midpoint, the vertex to the midpoint, and the vertex to the midpoint. Let's see how good I did this triangle. It was a little off, but they should meet in the same center. All right, guys. So give me a second. If you haven't answered the question already, give me a second to look through the chat. I keep doing that.